Hello everyone, welcome to the another very important session. So guys, today in this session we are going to discuss some more important questions and the concepts of atomic and molecular physics. So I hope that the discussion which we are going to do today in this session will be getting clear to all of you. But in case anywhere if you will be having any doubt, you can surely let me know about it and we will try to consider those points in the session then. Also, guys, I'm gonna talk about the latest offer which is going on Unacademy right now, as per which you will be able to get the great discount in the total subscription amount. Also, guys, to grab this offer, you just need to use and apply the code that is Anjali A Live as mentioned here on the screen. So the offer is just valid till 12th August, and then like if anybody will be taking the subscription when the offer will be going on, they will be able to get all this discount, and for that you just have to use and apply the code Anjali A Live. All the details about it have been shown here on the screen, guys. Also, what are the benefits you will get if you will be taking Unacademy Plus, Iconic or the Lite subscription? Let me just quickly show you all that. So actually, depending on which subscription you are going to take, you will be getting the respective benefits as they have been shown here. But if you will be taking Plus or Iconic subscription, in that case, even now the important notes are available on the learning app, which will be helping you to do the best preparation under the guidance of top educators. And guys, all these courses are gonna help you to take your preparation to a very good level. So I hope each and everything whichever you can see on this screen is going to help you a lot, and accordingly you can decide which subscription you want to take if you want to start your preparation under the guidance of top educators. And whenever you will be proceeding further to take the subscription, guys, use and apply the code Anjali A Live to get the discount in the total subscription amount. One more thing I would like to tell you, that even if any of your friends want to take the subscription and want to start their preparation under the guidance of top educators, you can share this information with them too. The offer is just valid till 12th August. So guys, if you don't want to miss it, you can grab this offer and get the discount in the total subscription amount. Okay, let me just show you a few more slides. Like this one is about the Unacademy learning app. This is about the session itself. This is something about me. This is related to community feature we are having on Unacademy, which will be helping you to get the latest updates and the important details and information. Now we are going to start the discussion about the questions and the concepts we will be taking in the session today. So guys, let's take the first question right now. It's here. Like we will start from something not so difficult. But still, if there will be someone like who is going to have any doubt or difficulty in considering this part, I'll help you. This is O. Try it now, guys, and if you don't know how to do it, I'll be helping you. Very good morning, Sakshi. So the first absorption spectrum, with the statement you will get to know they are talking about the absorption spectra. And for two different cases they have given you the values, and then their units are telling you these are the wave numbers. Okay, centimeter inverse and centimeter inverse. The ratio of their moments of inertia is what? That's what you have to consider. So here in this case, what's going to happen? In this case, it's going to be 2b, because the wave number separation in case of absorption spectra is what? Equal to 2b. So this is 2b, this is 2b. In that case, what will happen? It's going to be simply, when you are having this as 2b and 2b, you will be able to equate them with that part, and they are asking you to find the ratio of moment of inertia. So it's important here that you should know how the moment of inertia is related to the rotational constant. Okay, that's going to be our value of b. So b is inversely proportional, like to I. So in that case, what will happen? If you will take these ratios, you will have to take the reciprocal of i's on the other side. So 3.842, 3.673, and then you're gonna have, this is, you have written the absorption spectrum, the ratios of these two, 1 upon 2, but your moment of inertia will be inverse, I2 over I1. So you will have to see in the options every value is greater than 1, and that is only possible if you are taking this ratio, means what you are doing is correct. And if it will be less than 1 as well, so they will clearly mention that which ratio they want you to find. Is that the first to second or second to first, which one? Okay, so your right answer is what? It's option C. Very good, Sakshi, that's great. Let's take the next one now. If in case anybody is having any doubt, you can tell me, guys. The spin orbit interaction in an atom is given by H is equal to A L dot S, where L and S denote the orbital and the spin angular momenta. Respectively of the electron the splitting between the levels two p 3 by 2 and 2p 1 by 2 is. Options are 3 by 2 AH square, 1 by 2 AH square, 3 AH square, 5 by 2 AH square. Try it now, guys, and let me know what do you think is the correct answer. If you're not gonna get it, I'll help you in that case. So check it once. Let me know if in case there will be any doubt. Waiting for your reply, giving you some time, and then we'll be starting the discussion. Okay guys, let me just quickly tell you. So in this case, they have given you the spin orbit interaction in an atom is given by H is equal to A L dot S, right? Where L and S denote the orbital and the spin angular momenta respectively of the electron. The splitting between the levels 2p 3 by 2 and 2p 1 by 2 you have to consider. So in that case, what will happen? In this case, you have to firstly find that H value is what? A L dot S. So L is what? L into L plus 1, right? It's like that value will be giving you the value of L. And what about S? That's going to be S into S plus 1, but that's the square of these values. So whenever you will have this kind of L dot S term or any other dot product term, you will start by taking their sum and it's a square, because you know it's nothing but what? J squared, right? So it will give you L square plus S square plus 2L dot S, and from there you are just going to get the value of L dot S. So that will be L dot S is equal to J square minus L square minus S square divided by 2. What about J square? That's going to be J into J plus 1. H square minus L into L plus 1. H square minus S into S plus 1. H square divided by 2. Right? So you are having two different terms given to you which will have the respective L, S and J values, like this one and this one. So check out their LS and J values and then plug in those values here in this equation. When you will plug in those values in the equation, then find the difference of the energies of two levels, because you know in the energy term it's A L dot S. So L dot S you are finding, but A will also be staying there, like it will remain there, right? So if I'm going to talk about J, that's going to be what? L 2s plus 1 LJ. So J is 3 by 2 and J is 1 by 2. But all other terms are going to have the same value, because when you will compare it with 2s plus 1, okay, then you are going to get this value, 2s plus 1 this value, and your L value from the P part, that will be same. That's 1 for both. So only J is different, which is 3 by 2 and 1 by 2. When you will plug in the J values, so what will happen? 3 by 2 times 3 by 2 plus 1, which is going to be 3 by 2 times 5 by 2. Okay, and minus for 1 by 2, it will be 1 by 2 times 3 by 2, and then h square divided by 2. That's what you will have. Multiply a as well, because that's the part of h. Now in this case, if you will take 3 by 2 common, you will have 5 by 2 minus 1 by 2, which will give you 4 by 2, which is 2. So 2 and 2 will get cancelled out. You're just gonna get 3 by 2 ah square. Now see, what is your right answer? That's option A. So this is how you can simplify this type of questions, and this is quite simple and easy way to solve it. And I think you are going to get its answer quickly and easily this way. But still, if there is anybody who is confused about any of the steps and want to ask something, let me know. We can talk about it. And if everything is clear, we can go for the next question, guys. Let's take this one. separated. Try it now, guys. If you will have any doubt or difficulty anywhere in solving this, I'll be helping you in that case. But initially, I'm going to give you some time to tell me what is the right option. See, j is equal to 1 to j is equal to 0. So these states splits in a magnetic field of 0.1 Tesla, right? Into three components. So here you need to know there are two types of effects we study. One is going to be the normal Riemann effect, another one is the anomalous Riemann effect. So if we are going to talk about the type of, like, how you will identify what type of effect it is, right? Is it normal Riemann effect or is it the anomalous Riemann effect? So for that you need to consider how many components you're gonna get. If there are more than 3, it's anomalous. If it is equal to 3, it's going to be normal. So that means it's the normal Riemann effect, right? In this case, the spin will be 0. When a spin will be 0, J and L will be equal. Okay, so in that situation, if we are going to talk about the value of G factor you are going to have, then what will happen? Very good, Sakshi. So what will be your G factor value then? Do you know what G factor value you take corresponding to normal Riemann effect? It is 1. Okay, so that's what we need to know, and we can directly answer this question too. Or even if you will plug in the values in the Riemann effect, like the G factor formula, you will be getting still that, okay, it's 1, and that's your right answer. Let me just write the another one. the equilibrium population of states 2 and 1 are respectively. Try it now and let me know which one is the right answer according to you guys. And if you're not gonna get it, I'll be helping you in that case, don't worry. But still, I want you to try it first and to see like what you're gonna think is the right answer according to you. As you will get the answer, you can just mention it. What is the right option according to you? If you will not get it, I'll help you in that case, don't worry. So in this case, they have mentioned consider the energy level diagram shown below. So that's what they have shown. 0, 1 and 2 levels are there. Then pump rate and the decay rates from the two states. Okay, that's what is given, which corresponds to the molecular nitrogen laser. If the pump rate R is 10 to the power 20 atoms per centimeter cube per second and the decay rates are as shown with tau to 1 is equal to 20 nanoseconds, right? And tau 1 is equal to 1 microseconds. The equilibrium populations of states 2 and 1. Equilibrium population means after that no changes will take place, right? So in that case, if I'm going to talk about the change in the number of atoms present at the level 2, so that is dN2 over dt. On how many factors this will depend. This is the pump rate, the rate with which the atoms are reaching there. This is the decay roots and decay rates actually. This is going to be tau 1. So if you will talk about the change in number of atoms in the level 2, it will be R, which is responsible for taking or let's say the number of atoms which are reaching to the level 2. Okay, so tau R minus tau to 1, that's going to be what, n2 over tau to 1 we should have, because we want to talk about the rate, not just the time or the decay rate. Okay, so rate overall this. So rate means what, how many number of atoms are getting decay or moving from that level to the other level. So that is this rate, right? Now, if I will talk about the level 1, how the number of atoms are changing there with time. So you can see tau to 1 is responsible for taking the atoms to level 1 this way, minus n1 divided by tau 1, because this one is going and this one is reaching. So the reaching one is positive and the leaving one is negative, right? That's what you are going to have. If this will be in equilibrium, means these two values will be equal to each other, this and this. These two will be equal to each other. Okay, and at equilibrium what will happen, this value, the change will be 0, this will be 0 as well. So can you find the value of n2 with the first condition? Because you have everything, you have R, you have tau to 1, but you don't have n2. So you want to find the number of atoms, okay, in the different states or levels. So in that case, with the first condition you will get n2, and with the second, after finding the n2 you can easily find the n1, because you will have everything. You can just check it out like and tell me still if there is something not getting clear to you. We can talk about that part. But if everything is getting clear, guys, that's great. That means we are ready to take the next question. But tell me if something you want to ask. I'm still gonna give you some time, so you can let me know if you have any doubt even now. Done? Okay, guys, let's take the next one then. Still, if you want to ask anything, you can let me know. So your right answer is option B. I hope you all are getting same as option B values. Let me just give you the another one. try it now, guys. If you will have any doubt or difficulty in solving it, I'll be helping you in that case. But still, I want you to try initially and tell me what is the right answer according to you. If you will not get it, that's okay. I will explain it to you then. Waiting for your reply, guys. Very good, Sakshi. That's great. So let me just give you an idea about it, like those who have not got the answer. So, how much does the total angular momentum quantum number J change in the transition of chromium, that is 3d6 atom, as it ionized to 3d2 like 3d4 as chromium 2 positive? So in that case, guys, how the value of J will change, that depends on how the ground state corresponding J values are changing, right? With the help of that, you can answer it. So if I'm going to talk about the ground state J values, how we can find it, we will use the trick here to get the ground state J value. So the first case, D6 is more than half filled and D4 is the less than half filled. We also need to take care of that part because it affects our ground state spectroscopic term. D orbital can have total 10 electrons in it, maximum. So I need the 5 boxes, 1, 2, 3, 4, 5. First case, we are having 6. So I will be showing you that 1, 2, 3, 4, 5, and this is 6. ML values will be +2, +1, 0, -1, -2. So I'll have the +2 and -2 getting cancelled out. Then I'll have +2 remaining, +1 and -1. That is going to give me just 2. Okay. So that will behave as L, and summation MS will be equal to 4 by 2, which is just 2 again. So summation MS is equal to 4 by 2 we will get. You can take +½ -½ for first case, which will get cancelled out. Second one, +½ +½ +½ +½ which is 4 by 2, and that's going to be equal to 2, and that's your S value. J is equal to L minus S to L plus S, that is 0, 1, 2, 3, 4. Even here you can do it for the D6 instead of D4. You can also do it for instead of D6 you can also do it for D4, because we are having both of them, and these are inverted multiplets, right? And for the inverted multiplets, the total number of spectroscopic terms are always same, while the ground state changes because one is the more than half filled and the other one is the less than half filled case, right? So in that case, for less than half filled, the lowest J value will give you the lowest energy, okay, and the largest J value will give you the lowest energy for the more than half filled. So 0 is for D4 as a J value for the ground state, and 4 is for D6 as a J value. So it has changed from D6 to D4. That means J value has changed from 4 to 0. Okay, so that means it has decreased by the value 4. And which option is there? It's option C, which is saying the same thing. Hence our option C is the correct option. That's how you're just gonna get it. Please let me know, guys, if in case there is anybody having any doubt, and if it is clear, that's great. So if it is clear, I'll take the next question. If there is any doubt, you can just mention it. This is the latest offer slide, guys. To grab it, you need to use and apply the referral code. That's Anjali A Live, as mentioned here on the screen. Even you can share this information with anyone you think will require this, will need this, and want to start their preparation, because this is the limited time offer. So it is just valid till 12th August. Let me just give you the another question now. To the energy of nth vibrational level of a diatomic molecule is h squared omega, then try it now. If you will have any doubt, guys, I'll be explaining it then, but I want you to try it again first of all. Okay. If you are not gonna get it done, or you want me to start the discussion, you can tell me. Whatever is the correct answer according to you guys, just mention it in the comments. Okay. Very good, Sakshi. We will talk about it and we'll see like whether it's same or something different, okay? So let's have a look at the steps. But that's good that you tried. So actually in this case, if we will talk about the in general, what is the vibrational, like enharmonic oscillator energy we will have, the difference between enharmonic and the harmonic case is that in enharmonic case we will have this correction term, means enharmonic correction term, the extra term they have mentioned here. But in case of harmonic, we just have the formula for the energy, which is n plus half h cut omega, right? So your total energy this time will be n plus half h cut omega minus this zeta e n plus half square h cut omega, right? Now n is telling you about the number, like which state it is, right? So if you want to find how many maximum states are there, what you will do, delta E and differentiate it with respect to n basically. So when you will differentiate it and equate it with 0, can you tell me what is the value of n from here you are gonna get? Because that is the maximum value of n which will be possible. Let's simplify it. So what I'll get, I'll be differentiating it with respect to n, I'll get h cut omega from here. Then I'll have 2 zeta e n plus half h cut omega. This is equal to 0. So I can just simplify h cut omega parts. I'll have 1 here. So 1 will go on the other side, or this term will go on the other side. I'll have n is equal to, that's going to be 1 divided by 2 zeta e minus half, right? So it will give me simply, what is zeta e value? That's going to be 0.001, which will give me 1000, right? Divided by 2 minus 1 over 2. So it is what? It is simply 500 minus half. Half is quite a smaller value in comparison to 500. So you are going to get simply n is equal to 500. And this is going to be your final answer. So your final answer for this question is what? It's option A. Please tell me if in case there is still any doubt anybody is going to have, we can talk about it. Sakshi, let me know, did you get that? Like, okay, option A should be the correct, not the B. If you are not getting it, you can just mention it and I'll talk about whatever doubt you will have. But if you are getting it, that's great. So tell me if there is something not clear to you. And if everything is clear, that's very good. Okay, great. Let's go over the next one then. I think next one you will find easy now. Have a look at this. I'm writing the options here, guys. Try it now and tell me what is the right answer according to you. Waiting for your reply, guys. And then I will be starting the discussion just in some time. Again, you can see it's se.sp present here. So from where we will start solving it. Se plus sp and then it's a square. And Se dot plus sp will be your total spin or net spin S, which can have the values 0 or 1. Okay, because S1 minus S2, if you will take it as net spin, so it will be 0, and then if you will take it as S1 plus S2, that will be 1. So this is the hint. And then finally at the end you just have to get the difference between the energies, which is difference between the H values, one which you are going to write for S is equal to 0 and the other one which you are going to write for S is equal to 1. Waiting for your reply, guys. I think Sakshi has got B. Okay, let's talk about it. Very good, Sakshi, that you have tried. Let's see what is the right answer then. So if we have, I'm gonna start with SE plus SP and it's a square. We can put the vector on top. That will be SE square plus SP square plus S2SE dot SP, right? We want this. So when we want this is net spin S. So I will have SE dot SP is equal to S square minus SE square minus SP square divided by 2. And this will be S times S plus 1 H square minus SE times SE plus 1 H square and then minus SP times SP plus 1 H square. Now you know that in both the cases when I want to get the difference of the energies like the H dash values, I'll have electrons spin same, protons spin same. So I will just have this thing change. Okay. Now what is its value? One time I'll take 0, another time I'll take 1. It's 0 H square, that's just simply 0, and then 1 time 1 plus 1, that's 2 h squared square. So you are simply going to have the difference of these two as your final answer. Also, when you are taking 2 h squared square, that's only for this value, but when you will divide it by 2, it will be simply h squared square. Okay, so where is that a h squared square part? Option C, and that's your right answer. Look at the steps and tell me still if something is not clear. We can talk about it, but if everything is alright and clear, then that's great. So let me know, what do you think? Is there still any doubt? And if yes, you can mention it. If no, then that's great. Okay, great. Let's go for the next one. Try it now and let me know as you will get it done. Waiting for your reply, guys, and then I'm gonna start the discussion too. So 1 is 0, 3p 0, 3p 1, and 3p 2, 1d2, right? In this case, what is going to happen? You have to observe this term. What is this term? This is less than half filled case. For p orbital, you can maximum have 6 electrons in it. Right now it's just 2, which means it's less than half filled. And in that situation, what they have asked, are they asking for the ground state? Yes. You can see all the terms are different, but to get sure what will be the ground state, I would say you should follow the steps of the trick so that you will be getting exactly what is the ground state. What is the reason behind it? Because if let's say you are going to just look at the options, in that case, if any of the term which is given there and that's not actually existing term, right? So in that case, you may select a wrong answer. But if you will do it step by step like the way it needs to be done, you will be getting it right. So if I'm going to consider that part like P2, so p orbital can have maximum 6 electrons in it, right? So 2 here, right? So in that case, what will happen? Plus 1, 0, right? And minus 1. So summation ml is equal to what? It's going to be 1. And summation ms is equal to what? Half and half, that's again 1. So L will be 0, 1 and 2. Less than half filled case, so L value must be like the J value must be the lowest one. So if I'm going to consider, oh, this is J, L minus S to L plus S, right? So J must be 0. And if I will consider 2s plus 1, that's going to be 2 into s is 1, that's 1 plus 1. So that's going to be 3. And L1 gives you P, 3P and J value 0. So just with the help of this as L, this as S, this as J, I'm going to write the overall spectroscopic term for the ground state, that's 3P0. What is the right answer? It's option A, which is the correct one. Very good, Sakshi. That's great. Okay, yeah, you got it. Same. So it is the correct answer you're gonna have. If in case anybody is gonna have any doubt even now, you can just mention it, guys. But if it is clear, I'm gonna give you the next question then. So it's here. A diatomic molecule has vibrational states with energies that's going to be EV is equal to h squared omega, and that's like its vibrational quantum number, so E plus half, and rotational states with energies EJ is equal to BJ times J plus 1, where this is also J plus 1. Okay, if something is not getting clear, you can tell me. Consider the transitions in which both the initial and final states are restricted. Options are, this is 3B, Try it now and let me know as you will get it done. If you will have any doubt or difficulty anywhere, I'll be discussing it, guys. But if you're gonna get it, that's great. You can just mention it, whatever is the right answer according to you. So tell me whatever is the right answer according to you. Very good, Sakshi. That's great. That's correct too. Let's talk about it quickly. So basically for the EV, they have given us the formula for the vibrational energy, J, that's the rotational energy, and then they have given you the restrictions on them. So delta V can be plus minus 1. That's how you can take the transition. Delta J should be plus minus 1. And also the V values should be either less than or equal to 1. Means V is just going to have 0 and 1, two possible values, and only one possible transition is there. But for J, 0, 1 and 2, three possible values you have. So two ways there can be transition. In this case, only one way. So in that situation, if you're going to take the difference of energy corresponding to V values, by taking 1 and 0 there, when you will take 1, it will give you 3 by 2. When you will take 0, it will give you 1 by 2. So 3 by 2 minus 1 by 2, that's simply going to be 1. So 1 h cut omega you are getting. But for J, if you will take 0 and 1, then you are getting 2b as the difference of those energies. And when you are taking 1 and 2, you are going to get 4b as the difference of energy. So 4b is greater 1. So h cut omega plus 4b will be the largest allowed energy. That's how you can get it. Excuse me. Also, guys, if still there is someone having any doubt in this part, just let me know. We can talk about it. But if it is getting clear, that's great. I'll be giving you the next one. Okay, we need more slides. This is 1 as 0. Try it now, guys, and let me know what it do you think is the correct answer. The LS configurations of the ground state of 12 magnesium, 13 aluminium, 17 chlorine, and 18 argon are respectively what? That's what you have to find. Whichever is the right answer according to you, you can mention it, guys. Very good, Sakshi. That's great, and that's correct too. So to solve it, what we can do, we can see 12, 13, 17, and 18. Let's write the configurations for them. For 12, it will be 1s2, 2s2, 2p6, and 3s2. So in this case, the last term is completely filled. But if I'll talk about 13, so I will just have to write these all and then the last one as 3p1. It's not completely filled. In the next case, for 17, I'll have the last term as 3p5. The first all, and then the one extra term, right? For 18, I'll again have 3p6 at the end. So this is completely filled. This is completely filled and this is completely filled. So which will give you 1 as 0 at the as the first place and the last place. So 1 is 0 and 1 is 0. Only by checking out even which one is the completely filled, because they have mentioned respectively, means they have mentioned all the values in sequence. So we are going to get the first and the last one should be 1 as 0, and that's giving us option C to be the correct one. You can tell me if in case there is anybody having any doubt, we can talk about it. But if it is clear, that's great. We can take the next question then. I think we can take one more right now. Try it now and let me know as you will get it done. Or whichever is the right answer according to you. Waiting for your reply, guys. And then we'll be continuing the discussion. Okay, Sakshi, let's consider it. So, an atomic spectral line is observed to split into 9 components, okay, due to G-man shift. Now, here this part is important and this part is also very important. So, you need to know how to consider the number of components or the shifts like that, okay. So, it is having a formula for J1 plus 2J2 plus 1, where J1 should be less than J2 for the G-man effect. And depending on anomalous G-man effect, if there is any exception that this transition cannot be considered and that is present, so in that case, to exclude it, you just remove that one, otherwise it remains same, okay. So if any transition is present and you don't want to include it because of the exception in the selection rule, so you just remove that to remove that particular transition, okay, otherwise you take it. Now in this case, if I'm gonna take the J1 and J2 values, so one of the value which is given in the question is 2 for J, and the other one I have to select from the options. So let's say I'm taking 1 and 2. So 1 is a smaller, let's place it at place of J1. 4 times 1, that's 4, plus 2 times 2, because the other value I'm having 2 already, that's 4. 2 to the 4, 4 plus 4, 8, plus 1, 9. So I got to know my one of the, yeah, okay. So I was saying that the number of transitions or the components in case of G-man effect you can find with this formula, where J1 and J2 are having a condition associated with them that J1 should be smaller than J2. So one of the J values is given in the question, which is 2, right? And the other J value you need to decide from the options part. So options are having two choices, 2 and 1. These two are the choices you are having in the options. So I'm going to consider, okay, let's say other J value is 1. So when other J value is 1, so 1 is smaller than 2, I'll be taking it as J1. So 4 times 1 plus 2 times 2 plus 1. I am right now checking, is it giving me 9 components? So you will find like, oh yeah, 4 ones are 4, 2 twos are 4, 4 plus 4, 8, 1, 9. So it's correct. Means my other value along with 2 must be 1. If I'm taking that 2, because I just have 2 options. So then 4 twos are 8, 2 twos are 4 and 1. It's not giving you 9, it's giving you more than 9. So you got to know that either this or this will be correct, right? Now you have to check 3F1 and 3P1. 3F1. So when you are going to take L is equal to what? S, P, D, F, 0, 1, 2, 3. L is equal to 3. 2S plus 1 is equal to 3 means S is equal to 1 by 2. And J is equal to 1 here. So it will give you J is equal to what? L minus S to L plus S. Oh, did I consider 2S plus 1 is equal to 3? So S should be equal to 1. Guys, why 1 by 2? It should be 1. So J is equal to L minus S to L plus S, which is giving me 2, 3, 4, right? So you can see that I can't even have the J value to be equal to 1 associated with it if I'm following the steps and I'm trying to check it out. So that means 1 is not correct, which means 3F1 is a wrong notation. When it is a wrong notation, this cannot be the right answer. So your right answer will be option C. So firstly, I checked whether I should have a other J value to be 2 or 1 because I had these two options. Okay. Then I got to know it should be 1. Then I had two options associated with it. Then I checked the condition like 3f1, and I got like, oh, 1 is even not possible J value for 3f. So that means it's wrong and the other option is correct, which is option C. Sakshi, is that clear now? If it's still like you have any doubt, you can tell me. That's great. So what we will do, we are going to keep it this much right now in this session. And thank you so much everyone for joining this session. If there is someone like having any doubt or something is not clear, you can surely tell me. We will have more sessions on the other. In case of anomalous, you will prepare the selection rules. Like when you prepare the G-min effects, like the normal G-min effect and the anomalous G-min effect, you will study the selection rules, right? As per the selection rule, for the, let's say, delta J is equal to 0 to J is equal to 0, there is a condition which is the exception that corresponding to this J, for this particular condition, that is not a possible transition. So if any time there is something like not possible transition and that is present in the question, in that case you have to just remove this one if that exceptional case is present. So to study that topic in detail, you have to prepare the selection rules. These are important. And when you will prepare the selection rules, you will find that if any time that exception case which is in the selection rule, that it is not allowed case basically, so then you'll just remove one from that equation, otherwise it will stay there. Not every time in anomalous you have to remove it, just whenever that not allowed transition case is present, then remove it, okay? Otherwise it will remain same even in anomalous. Let's keep it this much right now. We'll have more discussion in the other sessions now, guys. And thank you so much everyone for joining this session. Also guys, right now, as you know, this is the latest offer which is going on. It's just valid till 12th August, and to grab it you can use and apply the code Anjali Live as mentioned here on the screen and get the discount in the total subscription amount. Thank you so much everyone for joining this session, and you can share this information with your friends too. Let them know about it as well. What are the benefits you will get if you will be taking the plus iconic or the light subscription? All that has been shown here on the screen too. Thank you everyone. Bye. Take care. See you in the next